sklearn, model selection, validation curve display. Description: a class to visualize the validation curve for a given estimator. Validation curves are used to determine the optimal value for a hyperparameter by plotting the estimator's performance as a function of the hyperparameter value. Inputs: estimator, the estimator whose performance is to be visualized. Paramname, the name of the hyperparameter to be varied. Paramrange, the range of values for the hyperparameter to be tested. X, the training input samples. Y, the target values. Groups, group labels for the samples used while splitting the dataset into train-test set. CV, the cross-validation splitting strategy. Scoring, a STR or callable to evaluate the estimator's performance. N jobs, the number of jobs to run in parallel. Verbose controls the verbosity, the higher, the more messages. Outputs: validation curve display, an object containing the visualization of the validation curve. Steps: the validation curve is calculated by training the estimator on a range of values for the given hyperparameter and evaluating its performance on a held-out test set. The performance is measured using the specified scoring metric. The results are then plotted to visualize the relationship between the hyperparameter value and the estimator's performance. Metrics: the metric used to evaluate the estimator's performance is specified by the scoring parameter. Common metrics include accuracy, precision, recall, F1 score, and AUC. Visualization plots: line plot showing the estimator's performance as a function of the hyperparameter value. The plot includes confidence intervals for the performance scores. Fine-tune parameters: paramname, the hyperparameter to be tuned. Paramrange, the range of values to be tested for the hyperparameter. Uncertainty methods: confidence intervals, the plot shows confidence intervals for the performance scores, which provide an indication of the uncertainty in the results. Challenges and fixes: challenge 1, the validation curve may be difficult to interpret if the hyperparameter range is too wide or too narrow. Sample use case: if the hyperparameter range is too wide, the plot may show a very flat line, which makes it difficult to determine the optimal value. If the hyperparameter range is too narrow, the plot may not show the full range of the estimator's performance. Fixes to challenge 1. Try adjusting the paramrange parameter to include a wider or narrower range of values. Consider using a logarithmic scale for the hyperparameter axis if the range of values is very large. Challenge 2, the validation curve may be noisy if the number of cross-validation folds is too low. Sample use case: if the number of cross-validation folds is too low, the performance scores may be highly variable, which makes it difficult to identify the optimal value. Fixes to challenge 2. Increase the number of cross-validation folds using the CV parameter. Challenge 3, the validation curve may be misleading if the dataset is not balanced. Sample use case: if the dataset is not balanced, the performance scores may not accurately reflect the estimator's true performance. Fixes to challenge 3. Consider using a balanced dataset for training and testing the estimator. Use a scoring metric that is appropriate for unbalanced datasets. Challenge 4, the validation curve may not be informative if the estimator is not sensitive to the hyperparameter being tuned. Sample use case: if the estimator's performance is not affected by the hyperparameter being tuned, the validation curve will show a flat line. Fixes to challenge 4. Choose a different hyperparameter to tune. Consider using a different estimator that is more sensitive to the chosen hyperparameter.